All right, we're going to go through the warm-up, the review questions that I wanted you to do to get ready for this quiz coming up. So our quiz is over sections 1.4 to 1.6. You are welcome to use all of your notes, including these examples on the quiz. So you want to make sure that you've done them on your own, that you've gone through and kind of watched me go through them to make sure that they are correct. So first one comes from 1.4. We are going to distribute the -2. So we have -2x minus 10. We still have the plus 4x and the -2. And then we're going to distribute the 4. So we have 4x minus 20. We're going to combine like terms on the same side of the equal sign. So I have x terms on the left side. 4x minus 2x is 2x. And then a -10 minus 2 is -12. And on the right side, 4x minus 20. We're going to subtract 2x. So we have -12 equals 2x minus 20. Add 20. So 8 equals 2x. Divide by 2. We get 4 equals x. To check your work on this, and really with a calculator, it's kind of nice. All you're doing is taking the 4, you're plugging it back into this original equation everywhere you see x, and making sure both sides are equal. So the other thing we did in 1.4, we did word problems and we did what's called literal equations. This is a literal equation. It's an equation, essentially it's like a formula, something that where your values represent different quantities, and we want to rewrite it. So currently it's solved for h. Our job is to get it solved for p. So I need to get p by itself. Whenever it says solve for a particular letter, that is the letter that needs to be alone. So first thing I'm going to do is get rid of the 1/4. The way I do that is I multiply by the reciprocal. So I'm going to have 4h equals rp. And then to get rid of the r, currently it's multiplied, so I'm going to divide by r. And that is your answer. That's how we go into rewriting a literal equation. We isolate the variable that we're trying to solve for. Now I want to do a few questions that were from section 1.6, so I'm jumping a little bit. 1.6 focused on absolute value equations and absolute value inequalities. So we're going to start with an absolute value equation. Anytime you're working with absolute values, whether it's equations or inequalities, you need to isolate the absolute value. That means get the bars alone. So we're going to add 2 to both sides. So I still have the 3, and then 2x plus 1 equals 15. Then I'm going to divide by 3. So I have 2x plus 1 equals 5. Once you have it isolated and it's an absolute value equation, you're going to break it down into 2 solution paths. One is going to be 2x plus 1 equals the positive 5, and one is going to be 2x plus 1 equals the negative 5. Subtract 1, and you can do that all the way across. So you get 2x equals 4, and then subtract 1, you get 2x equals -6. Divide by 2. Divide by 2. We get -3 as one solution. We get 2 as the other. Now, when you have absolute value equations that only have a variable on one side, your 2 solutions should both be valid. The way we check it is we just plug those numbers back into the original equation and make sure both sides are equal. If you have an absolute value equation that has variables on both sides, these were the ones that you have the potential of getting what's called an extraneous solution, meaning you are more likely to get a solution that when you plug it back in, it does not check. Moving on to the second one, this is an absolute value inequality. I still need to isolate the absolute value, so I'm going to divide by 2. So I have 3x minus 1 is less than 7. We had 2 types of absolute value inequalities. We had less than, they became ands, and we had greater, greater than, those became ors. This is a less than, so we are going to sandwich it between a positive 7 and a negative 7. You're always going to have your inequalities point to the smaller number, so they're going to point towards the -7. To solve this and inequality, we're going to add 1 everywhere. So we have -6 is less than 3x is less than 8, and then we're going to divide everything by 3. So we have -2 is less than x is less than 8/3 doesn't reduce, so I'm just going to leave it as 8/3. That is called set notation. My graph goes from, get rid of that, from -2 to 8/3. These are both open circles because they're not included. We're going to connect between it. Remember, an and inequality looks like a sandwich. And then my interval, since both of them are not included, we're going to put them in parentheses. from -2 to 8/3 in parentheses. So those are my set of solutions. The only thing you could do to check these if you wanted to is you could pick any number in that set, in that interval, and plug it back into the original inequality and make sure it's true. This is we're now kind of bouncing back and forth. I want to do different things with you. This next one is a literal equation that we're solving for x. So our job is to get x by itself. Again, when it asks you to do that, you want to get that variable by itself. This was also done in section 1.4. So first thing I'm going to do is I'm going to multiply everything by 2 to get rid of that 2 in the bottom. When I multiply everything by 2, I have to make sure I distribute that 2 through. So I'm going to have a 2m and a 2n, and that 2 is going to cancel with that 2. And then I need to get x by itself, so I'm going to add 2. I can't add it to any of the terms that are already there because they are not like terms. So we are going to add them all separately in any order would be correct. Next one is, now we're jumping back to the end of the topic when we did absolute value inequalities. This is a greater than sign, so I know I need to make it an or inequality. But first, I need to isolate the absolute value. So I'm going to add 3. So I have 1/9 absolute value of 5x minus 3 is greater than or equal to 5. Multiply by 9. So when I multiply by 9, that gets rid of the 1/9. And on this side, I have a 45. Now with a greater than, we turn it into an or inequality. So the way we write an or inequality is we write the original inequality, just drop the bars. And then we say or 5x minus 3 is less than or equal to the opposite of 45. So when you have your greater, it's an or, so everything goes opposite directions. So you're going to have one piece that's bigger than the positive, and you're going to have one piece that's smaller than the negative, creating that opposite look. Now we're going to add 3. Same thing here, add 3. So we have 5x is greater than or equal to 48, or 5x is less than or equal to -42. Divide by 5. So you have x greater than or equal to 48/5 and x less than or equal to -42/5. If you'd rather write those as decimals, you can, but leaving them as a fraction is perfectly fine. So on my graph, I'm going to put the smaller number, -42/5 here. That's really messy, I apologize. And then the bigger number, 48/5 here. Both of them are closed circles because it has the or equal to, so I'm going to fill in that circle. We're going opposite ways, so less than the -42/5, greater than the 48/5. And finally, my interval, this one's going to go from -infinity to -42/5, and we're including 42/5, and we're joining, or we're uniting that with 48/5 to infinity. And then I have one problem left. This is from section 1.5. This is a single inequality. Single inequality, we can tell it's a single inequality because it only has one inequality symbol. I know there's a lot of stuff going on here, but it is just a single inequality. So first I'm going to distribute the -2. So I have 8 minus 2x minus 12 plus 6x is less than or equal to, I'm going to distribute the 2x minus 8. Combine like terms. -2x plus 6x is 4x. 8 minus 12 is -4. So now I want to get all the x's on one side, so I'm going to subtract 2x. So 2x minus 4 is less than or equal to -8. Add 4 to both sides. And finally divide by 2. You do not need to switch the inequality because you didn't divide by a negative number, you divided by a positive 2. When you do a single inequality, in the end, your set notation will still just have that single inequality. So my set notation is x is less than or equal to 2. The graph, or -2, excuse me, should be a closed circle, and it should be heading to the left because it's everything that is less than or equal to -2. And the interval, it goes from -infinity to -2, and -2 is included. It has a closed circle, so we put a bracket there. So that is everything that we did in the beginning of section 1.5 with our single inequalities. We also got a chance to practice our compound ones with some of the earlier questions, and that really takes you through everything you need to know to be successful on this quiz.